We're working on length of names again. Somebody says that the real average length of name at Elk Grove High School is 15 letters long. That's what they're saying. They said they've already proved it. Trust me. This pill works. This pill cures cancer. Trust me. Well, no, we're going to test it out. I think you're lying. Okay? All right, so, Annika, help me out here. So if somebody says that the true length of names is 15 letters, you think it's smaller, what would we say our null hypothesis is then? HO?
HO equals 15.
HO
equals the mean, which equals 15.
Equals 15, yes. We use the equal sign in the null hypothesis. Okay, you're going to see it sometimes with inequalities on it. We use the equal sign. Okay, that's what we're going to go with. All right, so based on what we're trying to prove here, what would you say the alternate hypothesis is?
The mean is less than 15.
Less than 15. That's what we're trying to prove. We're trying to prove them wrong. All right, you went and took a sample. You got an X bar. One of those X bars up there on the wall. We're trying to figure out how likely it is that you get an X bar like Annika got if the real mean was 15. All of you right now have a different p-value. We're going to work on yours now. So let's draw the picture. So remember, we're going to assume you're telling the truth. So these are all of the X bars if the mean really was 15. And what'd you come up with? What was your X bar?
12.3.
Well, it's less than 15. My one little X bar is less than 15, but we want to ask ourselves the question, how likely was that? Okay, what'd you do now?
Wrote my formula.
Which is?
Z equals X bar minus mean over standard deviation divided by the square root of n.
Just looking at our numbers, 12.3 minus 15. Standard deviation 2.5, and what was your sample size?
20.
20. Okay, and what'd you get as your Z-score?
Negative 4.2.
Wow. It's off your charts, isn't it? So what were the chances you'd get an X bar like you got if 15 really was the mean?
0.
No chance. So let me ask you this question. Based on this p-value, do you feel you have enough evidence to call that person a liar? To reject 15?
Yes.
Why? Okay, now this is key now. She gave me a yes, but I don't think she believes herself. Why do you think you can call that person a liar now?
I'm just a little confused, I guess, because I guess we have 0% chance it's less than 12.3.
12.3 or less.
Yeah.
Okay, so here's what this means. If the real mean of all these was 15, there's no sample in here that would be 12.3. It's impossible.
Sorry.
There's no way. None of those X bars is going to be 12.3 or less. Is your less part that's bothering you?
I think so.
Yeah, I mean, it's just, it's like we're saying, okay, we'll give them that and everything else. It's impossible to get any X bar like you got, or worse. This can't be true. There's no X bars out there that are 12.3 or less. Yeah, 15 can't be right. I reject you, 15. You're lying. Last period. Someone got this. Now, you all have different p-values, but somebody got that. I asked them. I said, well, you'd be able to go on television and call a person a liar? And they said, no, there's still a chance. That person should play the lottery. Come on, that's so unlikely. Are you kidding me? You got that lucky that you found that sample. What p-value did you get?
0.
You got a 0. Anybody get a p-value that actually was a percentage a little bit? 5%. What'd you get?
5%.
You got a 5% p-value?
4.
You got what?
4%.
4%? All right, now these are a little bit more interesting. So what if you do get a p-value, let's say, of 4% here? So let's remember what that means. If the real mean of all of these length of names was 15, man, only 4% of the sample, the X bars in here, would be like what you got. It's pretty unlikely. Okay, is that unlikely enough for you to go on television and call him a liar? Is that enough evidence for you? Remember that, our judicial system. Think about what they do. Right? We assume someone's innocent. Prosecutor's trying to prove him guilty. Now, you mock trial freaks, what's the level they have to get over to be able to prove him guilty? Beyond a reasonable doubt. Is that 100%? Would you say beyond a reasonable doubt is you're 100% sure? No way. No way. So we're going to talk more about this, but at what level, at what p-value are you willing to call a person a liar, or at what p-value are you not? If I got your X bar, I got no problems. Okay. We'll talk more about that. Okay? In fact, let's talk about it now. All right, so more, just kind of a little bit more formal definitions here. What is p-value? This should make a little bit more sense to you now. Assuming that what they claim is true. Okay, I'll assume that 15 really is the true mean. What were the chances of getting the X bar I got? What were the chances? If they're so low, if it was like, come on, man, there was no way I'd get an X bar like, there was like a 4% chance to get an X bar like that. Then you have evidence to say they're lying. Their claim's wrong. So, next logical question is, well, where are we going to make that threshold? Where are we going to be able to say the person's lying or the person's not lying? Founding fathers, not the important ones, but the other ones, they came up with like beyond a reasonable doubt. That's what they decided the threshold was. Okay, you have to make a decision on what that threshold will be for you. We have a name for that. It's called the significance level. At what point are you going to be able to reject what they say is true? How much evidence do you need to reject that person's claim? It's called the alpha level. You'll also hear it called the alpha level. So what do you think? What kind of alpha level do you think is reasonable? Are you going to go on television and call this person a liar? You're going to refute their claim. You're going to say they're wrong. What do you think? At what p-value are you going to be happy to reject them?
Is it like a set number?
Yeah, so like we're going to set a percentage, and if our p-value is lower than that, in other words, it's even more unlikely than that I'd get a sample like this, then I'll reject that. So what do you think are reasonable alpha levels? Yeah. 10%. 10%. That is one. Now, just to understand something. Let's say you set it at 10%, and you go get a p-value of like 9%. That means 9% of those X bars are okay. What they say is true is right, and 9% of these is okay, but 10% is an alpha level that's used. I heard 5%. That's a very common one. If you want to be sure, if you're a scaredy cat, to call somebody a liar, and maybe you should be, 1% is a reasonable significance level as well. Okay? We'll talk more about how we set the significance level down the road. All right, and it brings up a very, very important concept in statistics. It's called statistically significant. Beyond the element of chance. Look, if I flip a coin 100 times, could I get 52 heads and 48 tails? Is that within the element of chance? Could that happen? Sure. I wouldn't say that's a bad coin. But if I got 99 heads and 1 tails, all right, that .0002 guy is probably going to say, that could happen. No, it can't. That can't happen. You need to reject that coin. There's something wrong with that coin because it's beyond the element of chance. It's kind of what we're doing here. Come on, there was no chance of getting a sample mean like 12.3. There's no chance of that. That's beyond the element of chance. So if we do get a p-value that's lower than that alpha level, we're going to reject what they said was true. Okay? All right, like I said, I just wanted to show you this today. This is going to be the form that we use. You're not doing this tonight. We'll be doing this tomorrow, but I want to show you what this is going to look like if you're asked to do a hypothesis test. You're going to tell me what the population parameter is again. What are you trying to predict for? Null and alternate hypothesis, like you did for the warm-up. We're going to set this significance level. Quite often, they'll give it to you in the problem. Set it with an alpha level of 5%. Okay? Sometimes they don't. You can make it up, whichever one you think fits. We're going to do our assumptions like we've done before. That's the test statistic which you used in calculating your p-value. And then here is going to be this. You're going to draw the picture. You're going to plug in the numbers. You're going to go find what that p-value is. All right, now this is the ugly part again. Remember we had that big old long sentences that we wrote up for the confidence interval? We have the same thing here. It's going to be 3-sentence conclusion. The first sentence is you're going to explain to the reader that you know what p-value means. You're going to write this sentence so many times between now and the end of the year, you will understand what p-value means. The second sentence is we're going to do this comparison. We're going to compare the p-value and the alpha level. And then the third sentence is going to be, what do you got? Are you going to reject them or not? So, like I said, I change this every day. This is kind of what we got now. Assume that the true mean length name at Elk Grove High School is 15 letters. Okay, I'm going to assume what you're saying is true. The chance of getting a sample mean of 12.3 or lower is, what did we say, 0% for you? Since the p-value of 0% is lower than the alpha level, which, I don't know, let's say we said it was 5%. Based on what you said, we will reject the null hypothesis that the mean is 15. And we do have statistically significant evidence to say that the true mean is less than 15. Okay, so that's how we're going to tie it all together at the end. Again, you're not going to be doing this tonight, but that's where we're going. Okay? Questions or comments? These are the big three today. P-value, significance level, it's our threshold. Under that, we'll be able to reject. God, there's no chance of getting an X bar like that. That was even below what I was willing to accept to reject them. And then what statistically significant means. Wow, it was so unlikely that I'd get that sample mean. I'm rejecting you, 15. Okay? Questions, comments?